Welcome to this video. Only 27 days until GCSE Maths Paper 1 begins. Today, relatively short one. I'm just going to recap the basic laws of surds. There's not anything in here about sort of expanding brackets of surds, rationalizing the denominator. I'll do that another day. This video is really just about recapping the basics. So yeah, watch along and give things a go. Make sure you're confident on these skills, and then you can check them off your revision list. So here are the four sort of basic rules of surds. So the first one is just about multiplying surds, and the rule is that if I multiply two surds, so I've got the square root of a multiplied by the square root of b, well, they can all be squashed under the same square root. So that is equal to the square root of a times b, or just the square root of ab. So for example, if I did the square root of 3 times the square root of 3, the square root of 2 times the square root of 3, that is the square root of 2 times 3, which is root 6. Okay, so we can squash things all under the same hat, all under the same surd. The next example, it's basically a shortcut, but it's the same rule as before. Well, I know that if I do the square root of a times the square root of a, I get the square root of a times a, and that's the square root of a squared. Well, those two things are inverse operations. They're the opposites of each other. The square root of a squared is just a. Okay, so don't need all that rubbish. That is just, the square root of a squared, which is just a. Okay, so if I take a square root, multiply by itself, we just get what's inside of the surd, just a. Okay, the third one we've got here let's have a look at a few examples of that. So for example, if I had the square root of 3 multiplied by the square root of 3, I get the square root of 3 times 3, which is 9. Root 9, which is 3, and that's why it works, is because when I do the multiplication, a number times itself, I get that number squared and then I square root it. So for example, if I did the square root of 7 times the square root of 7, I get the square root of 49, and the square root of 49 is just 7. So we don't need to really worry about that middle step. We can just focus on the fact that if I'm multiplying a root by itself, it sort of undoes it. Okay, the third example we've got, the third law is when I've got a multiple of a surd multiplied by another multiple of surd, and basically the way I like to think of these, I'm actually going to start with the example here. So in the red ink I'm just about to draw, if I did 2x multiplied by 5y, then how I would deal with that is to worry about the numerical parts first. So I do 2 times 5 is 10, and then worry about the letters. So x times y is just xy. So the same thing, well, the same sort of principle works for these. So if I'm doing a root b multiplied by c root d, what I'm going to worry about first is just the whole number parts out the front. So a times c would just be ac, and now I worry about the surd. Now I'm going to do, let's highlight this in green, so let's now do root b times root d. Well, I know what happens with that from the first thing we did. The square root of b times the square root of d would just be square root of bd. Okay, so let's look at that in practice. So in red's pen, let's do, if I do the 5 square root 3 multiplied by 2 root, 7, then let's do the whole number parts first. 5 times 2 is 10, root 3 times root 7 is root 21. Okay, last one here, when I divide things. So this last example is exactly the same as if I wrote the square root of a divided by the square root of b. Those are exactly the same thing. Then it's the same idea as multiplication, really. I can put it all under the same square root. So it's the same as root a over b. So for example, if I was doing, let's put this one in green, shall we? So if I was doing root 15 divided by the square root of 3, that's the same as the square root of 15 divided by 3, which is the square root of 5. Okay, and the same idea extends. If I had multiples, I would do the whole number parts, divide the whole number parts, and so on. Let's put these into action then. So certainly in both the foundation and higher tier exams, you're likely to be asked to simplify surds. So let's give these some numbers. Let's do question 1. So if I'm asked to simplify root 50, what I'm doing is I'm looking to find any square factors and to cancel them out. So for example, if I was simplifying square root of 36, that would just be 6. So I'm looking to do that for any square numbers that go into 50. I'm quite confident with my square numbers, if I do say so myself. If you're not, what I would really recommend doing is writing down at the top of your page or at the side of your page all of your square numbers. Okay, 1, 4, 9, 16, 25, 36, 49, 64, 81. I've run out of room now. But I'm going to write that on every page because that's what helps me to just spot which one of those numbers is a factor of the thing I'm trying to simplify. Okay, so the 50, well, I'm looking for the biggest one of these numbers along the top that is a factor of 50. Well, I can see, well, 25 goes into 50. It goes into 50 twice. Nothing bigger than that is a factor of 50. So what I'm going to do, in fact, let's absolutely circle that. So the square root of 50 can be split into the square root of 25 times 2. Okay, so it's exactly the same as the square root of 25 times 2. Then I'm going to apply that first law of surds, but in reverse. I'm going to split that up into the square root of 25 times the square root of 2. And now I know the square root of 25 is just 5. And then I'm going to multiply it by root 2. I'm not going to write in the multiplication symbol. I just write it as 5 root 2. Okay, there we go. So those things are equivalent, and that is considered a simpler form. Let's do the square root of 44 then. So same idea. I'm looking for the largest factor of 44 that is square, and I can see it's 4 11s. So I'm going to simplify it into the square root of 4 multiplied by the square root of 11. The square root of 4 is 2, and then there we go. Sorry, I've skipped that first step, but hopefully you can see how I get there. So it's the same as root 4 times 11, so I can split it up and simplify the root 4 into 2. Last one, this one's slightly different. It says simplify root 32 fully. So what I would really encourage you to do is look for the biggest number that goes into 32 that is square, and I can see that's 16. So that's square root of 16 times 2, which is square root of 16 times the square root of 2, and root 16 is just 4. So this simplifies to 4 root 2. Now, some of you may have not seen that 16 is the biggest factor, and you might think, well, I know that 4 eighths makes 32. So you might have split it into square root of 4 times 8. Now, if you don't find the biggest factor, this becomes a little bit of a faff, to be honest. So the square root of 4 becomes, well, so we split this up into root 4 times root 8, and then the square root of 4 is 2, so it's 2 root 8. But you then need to check, can I break down 8 any further? Well, yeah, 8 divides by 4. So I could break this down further into square root, 2 root 4 times 2, which is 2 root 4 root 2, and then square root of 4 is 2, so we get 2 times root 2, and then 2 times 2 is 4. Okay, so you can see that method is a lot longer, so it's really worth taking the time to try and find the biggest square root that goes into, the biggest square number that goes into our surd. Right, let's multiply these then. So I alluded earlier to the fact that the quickest way to do these is to deal with the whole number parts first. So let's do 2 times 4 is 8. Then do the surd part. Root 3 times root 5 is root 15. Okay, so on the second question, 2 times 2, still the whole number parts. Okay, whole number parts, 2 times 2 is 4. Then deal with your third parts. Root 13 times root 2 is root 26. What we need to do with these, by the way, is just check we can't simplify these down any further. Are there any square numbers that go to 26? No, so we're done. Okay, last one we'll do in purple. So take the whole number parts. 7 times 8 is 56. And then I've got the square root of 3 times the square root of 3. And if you think back to that very first slide, the one where we talked about our laws of surds, if I multiply a square root of a number by itself, it is just that number. So root 3 times root 3 is just 3. So that comes out as 118. Okay, it comes out as a whole number. Okay, same idea for dividing surds. So the square root of 30 divided the square root of 6 is root 30 divided 6, which is just root 5. Root 56 divide root 7, that's root 8. Okay, you do need to check that things don't simplify. Well, do any of our square numbers go into 8? Yeah, 4 does. Okay, so I could split this into the square root of 4 times 2, which is root 4, root 2, and the root 4 is 2, so that is 2 root 2. Last question then, divide any numerical parts. Well, there isn't one on the second number, so this 7 doesn't get divided by anything, so 7's going to be in my answer. And then the root 30 divides root 2, put them all under the same surd, and so that surd becomes root 15. Okay, last slide here then. If I'm looking to add and subtract surds, what you need to do first is make sure everything's in its simplest form. So take your time to simplify root 8. I'm going to write down my square numbers at the top just to make my life a bit easier. Okay, because I find it, even though I'm really confident with my square numbers, it just makes my life a bit easier to see my factors if they're on my page. So 8, well, 4 divides that, so that splits into root 4 times root 2. And then root 4 is just 2, so it's 2 root 2. Okay, and I'm done. With root 18, so 9 goes into 18, so this can be rewritten as root 9 times root 2, and then root 9 is just 3. Okay, so this breaks down to 3 root 2. So I've got 2 root 2 plus 3 root 2. Overall, I've got 5 lots of root 2. Okay, see if you can do the next one. So 50 breaks down into root 25 times 2. Or let's just write it quickly. So it's root 25 root 2. Root 25 is just 5, so that's 5 root 2. Same drill for root 8. I mean, we've just done this, but it's root 4 times root 2. Root 4 is 2, so it's 2 root 2. I'm adding these, so this time I've got 7 lots of root 2 in total. And same thing for subtracting surds. So root 200, well, I can see 100 goes into that, so it's root 100 times root 2, which breaks down to 10 root 2. And root 32, well, 16 goes into that, so it's root 16 times root 2. Root 16 is just 4. So we're subtracting 10 root 2 and 4 root 2, which overall leaves us with 6 lots of root 2. Okay. Hopefully you've found that to be a useful recap on the basic laws of surds. If you're thinking, boy, I really wish we did some rationalising the denominator there, well, you can look out for that in a future video.